Hello guys, welcome to another video of structure analysis. Today's topic is truss analysis using Hypermesh. Truss structures are all around us. Famous examples are the Eiffel Tower and the Cornell University. In this video, we're going to analyze a simple example of a truss structure. On the left-hand side of the screen, you can see the dimensions of the truss structure as well as the value of the loads that are applied to it. On the right-hand side, you can see the arrows that represent the reaction forces on the supports. It's important to point out that those arrows represent an estimation of the direction of the reaction forces. The result on the rightmost part of the screen, the analytical solution are listed. So we're going to try to obtain the same result using Hypermesh, or in other words, using the finite element method. There are six main steps that we have to follow to carry out the analysis. Firstly, we create the geometry, then we create the mesh, then we define the material and we assign the properties to the mesh. Then we create the loads and the boundary conditions, and we create a load step that contains the boundary conditions and the loads. Then we run the simulation, and finally we can view the results. Step 1. Creation of the geometry. The first thing that we do when we open Hypermesh is to choose the right profile. In this case, we want to choose the OptiStruct profile. When it comes to the geometry, we're going to create only three nodes. Those nodes represent the endpoints of the truss structure. So the first node is located at the 0, 0, 0 point. Then the second point is located at the 4000, 0, 0 coordinates, which means that we are using the millimeter for the length unit. The creation of the third and fourth point are just straightforward. So now we have completed the geometry creation. In this simple example, this step is quite simple, but in more complex problems, you might spend more time in the creation of the geometry process. Step 2. Mesh creation. For the mesh creation, we use 1D elements. For that, we go to 1D panel and we select bars. Then in this panel, we define the orientation of the 1D elements. In this case, it's the z-axis. And for element type, we choose C bar. Now we proceed to create the four 1D elements that represent the truss structure. Step 3. Material and properties. First, we create the material. This is a random material, and the material really does not matter in this case, as we are only seeking for the reactions forces in the nodes. So the material is just not important. Anyway, we have to create it for the analysis. Once the material is created, then we proceed to create the property. We change the card image to P bar. We have to create a section for this P bar property. Now we assign the section under the material that we have just created. So at this point, the property creation is finished. Now we should assign the property to the component, in this case, the C bars.